Let's suppose for a moment that we wanted to make a list of all of the factors of some number. How could we come up with them, and how could we know that we'd gotten them all once we did? Well, in order to get them all, we have to go through and systematically divide by every number. Well, wait a minute. If we try to divide by every number, we're going to be here for a while because the numbers go on forever. Let's see if we can narrow it down. Well, the first thing we notice is no factor will ever be bigger than our number, right? Because when we multiply by 1, we get our original number back. If we multiply by anything bigger than 1, well, the answer is bigger than either factor. So no factor will ever be bigger than our number. That tells us that we don't need to multiply by every number, just one smaller than the number we're trying to factor. But we can do even better than that, because we remember that factors come in pairs, right? Whenever we have a multiplication sentence, there are 2 factors that show up in that multiplication sentence. And of these 2 numbers, either they're the same number or one of them is smaller. That means if we start at 1 and divide by one number at a time, we can stop dividing once the quotient is at least as big as the divisor. This is going to seriously cut down on how long it takes us to find all of the factors of a number. We just have to remember, we're using this fact that factors come in pairs. We have to remember to spot both factors in the pair. All right, let's see how this works. Let's find all factors of, for example, 24. Right, so we're going to go through systematically and divide by each number. We'll do 24 divided by 1. Well, we know what that is. That's going to be 24. This division sentence is the same as the multiplication sentence. 1 times 24 is 24. And we'll always get this one. This shows us that 2 of the factors are 1 and the number itself. That always happens. Next, 24 divided by 2. Well, 24 doesn't show up in the 2 row of our multiplication table, and the last number in that row is smaller than 24. So 2 might go into 24. We don't know. Let's try that division. 24 divided by 2. Well, 2 goes into 2 once. Bring down the 4. 2 goes into 4 twice. Nothing left over. So, yes, 2 is a factor of 24. In fact, 2 times 12 is 24. Again, we've found not just one, but a pair of factors, 2 and 12. Let's try 3. Well, looking at our multiplication table again, 24 is in the 3 row of our multiplication table. In fact, 24 is 3 times 8. All right, what about 4? Well, hey look, 24 is also in the 4 row of our multiplication table. It's 4 times 6. All right, what about 5? Oh, no, 24 does not show up in the 5 row of our multiplication table. 24 comes between 20 and 25. We see that 5 times 4 is 20. If we have 24 things, we can make 4 groups of 5, and we'll have 24 minus 20 is 4 left over. 24 divided by 5 is 4, remainder 4. Therefore, 5 is not a factor. More than that, we see that the quotient is now smaller than the divisor, so we stop. And we can now make a list of all factors of 24. They are, I'll go down this column, 1, 2, 3, 4, and then up this column, 6, 8, 12, and 24. I have to be careful not to forget that 1 is a factor of 24, and 24 itself is a factor of 24. I'm going to give you one of these to try. Find all factors of the number 78 by going through and systematically dividing. Pause the video and try this now. Alright, 78 divided by 1 is easy. That's 78. So 1 times 78 is one pair of factors. 78 divided by 2, 78 is bigger than the biggest thing in the 2 row of my multiplication table. So I'll do that division. 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. Bring down the 8. 2 goes into 18 9 times. 9 times 2 is 18. So remainder 0, we have a factor. 78 divided by 2 is 39. 2 times 39 is 78. 78 divided by 3, well, 78 is bigger than the last number in my 3 row. So I'll divide 78 by 3. 3 goes into 7 twice. 2 times 3 is 6. Subtract. Bring down the 8. 3 goes into 18 6 times. 6 times 3 is 18. Nothing left over. 78 divided by 3 is 26 with no remainder. So 3 and 26 are both factors. What about 4? 78 is bigger than the biggest number in my 4 row. So I'll divide 4 into 78. 4 goes into 7 one time. 1 times 4 is 4. 7 minus 4 is 3. Bring down the 8. 4 goes into 38 9 times. 9 times 4 is 36. 2 left over. So 78 is not a factor. I'm not going to write out that phrase. So 4 is not a factor. There's no multiplication sentence we can write here. How about 5? 78 is bigger than the biggest number in my 5 row, so we'll divide. 5 goes into 7 one time. 1 times 5 is 5. Subtract, there's 2. Bring down the 8. 5 goes into 28 5 times, because 5 times 5 is 25, with 3 left over. Again, not a factor. How about 6? 78 is bigger than the biggest number in my 6 row, so I'll divide again. 6 goes into 7 one time. 6 goes into 18 3 times. Nothing left over. Yes. 6 times 13 is 78. So 6 and 13 are factors. How about 7? 78 is bigger than the biggest number in my 7 row, so I'll divide. 7 goes into 7 one time. Bring down the 8. 7 goes into 8 one time, with 1 left over. So this is 11 remainder 1. 7 is not a factor. How about 8? 78 is bigger than the biggest number in my 8 row, so I'll divide. 8 doesn't go into 7, so 8 must go into 78 9 times, with 6 left over. 8 is not a factor. What about 9? 78 is between 72 and 81 in my multiplication table. So 9 must go into 78 8 times, with 78 minus 72 is 6 left over. Now my quotient is smaller than my divisor, so I stop. And now I look over here and I see the list of all of my factors. I have 1, 2, 3, 6, 13, 26, 39, and 78. Now, if you don't want to make this list of multiplication facts, notice that you could read this list off of just your list of division. If you're not writing down the multiplication, cross off the rows where you got a remainder so that you don't mistakenly think that, for example, 7 is a factor of 78.